So I'm recording the discussion of number 27, page 140. This is from section 3.4 from the textbook. So you're asked to find the average cost of producing 100 washing machines. When you're doing that, what you're doing is you're doing C of 100 minus C of 0 over 100 minus 0. It's an average rate of change. Going from 0 to 100 washing machines. So if you don't produce anything, that's $2,000. So it means that you're spending $2,000 just for keeping the factory open, right? Or yeah, because you're producing washing machines. So like maybe that could be rent or utilities or whatnot. But if you're producing 100 machines, apparently you make some money. Sorry, it costs you some money. Plus 100 times 100 minus 0.1 times 100 squared. So that's 11,000. So that's the cost if you produce 100 machines. So if you take the slope there, you should be getting oh, well, that's strange. Hold on a sec. Oh, I'm totally overthinking this one. I'm sorry. You just do this. I'm totally overthinking this one. You just produce 100 machines. Just get the cost of 100 machines and divide by 100. My apologies. I'm totally overthinking. It's not the average rate of change. But I totally apologize. The average cost is simply $110. You're just taking C100, which is $11,000, divided by 100. So it's just $110 per machine. That's average cost. My apologies. I totally overthought that one. Now the marginal cost, that's going to be the cost of producing the 100th machine, essentially, or what's going to be the instantaneous cost. So in this case, you do C prime of 100. Well, C prime of X is just going to be 100 minus 0.2 times X. So when you plug in 100 into that, that's going to be 80. So what that really means is that the 100th machine cost you $80 at that moment that you made the 100th machine. And for C, show the marginal cost in 100 machines are produced is approximately the cost of producing one more washing machine after the first 100 have been made. So what you do for that one, for part C, that might be a little confusing, is you want to do C101 minus C100 over 101 and over 100. So we know that the average of making 100 machines was $110. And if you make 101 machines, so if I were to do 2,000 plus 100 times 101 minus 0.1 times 101 squared, I get 11,079.90. And actually, I don't know why I'm just messing this up. You're really just doing this. My apologies. I probably need to do another recording for B period. I should have worked this out beforehand. You're just doing C101. C101 was this. That's the cost of producing 101 machines. That's the cost of producing 100 machines. So the 101st machine you made cost you an extra $79.90. Remember, the 2,000 was the fixed cost. If you don't produce anything, it's $2,000. And as time passes, the cost per machine goes down because now you're spreading this cost over several machines. The fixed cost gets spread out. Sorry for being a little rusty with this problem. So that's that one. And then lastly, for the other ones here, for the worksheets, let me pull that up really quickly here. So you're trying to find Ben's acceleration at t equals 5. You're just going to do this. You're just going to do B10. Sorry, it's acceleration. So you're going to do V10 minus V0 over 10 minus 0. Because remember, acceleration is the derivative of velocity. And 5 is right in between 0 and 10. So you're just doing that. So this is 2.3 minus 2.0 over 10, or 0.3 over 10, which is 0.03. Do you have to give the units? They will not give that point on the AP exam. So you have to say meters per second squared. For number 2, 7 is halfway between here, and you're trying to find the change in temperature versus distance. So in this case, you're going to say 55 minus 62 over 8 minus 6, or negative 7 over 2, or negative 3.5 degrees Celsius per centimeter for that one. And lastly, for the other one here, 36 is halfway between these two numbers. And it looks like we're trying to find acceleration again, which is derivative velocity. So you're going to do 7 minus negative 4 over 40 minus 32. So 11 out of 8, or 1.375. And the units here are going to be meters per second squared. So that's all you're doing for those problems. So hopefully that, that all makes sense. Okay, so I'll clear my drawings. Let me stop that recording.